This prototype is a mock-up of the complete physical system that consists of multiple components. The three unlocking mechanisms we implemented are swipe access, pin code input, and a simulation of a mechanical key which will turn a deadbolt to press a button. The current prototype will only be utilizing one of the locks for ease of a prototype demonstration, whereas our final project will include all three locks for each different component. For the final demonstration, we will clean up the wiring, as well as I stated, incorporating all three locks. The prototype proves the viability of each of the unlocking mechanisms and allows us to move forward with the development of the Apache database and GUI design, which will be further integrated into the final product. A rough draft of each of these, the Apache database and the GUI mechanism, have been created, and they will be demonstrated shortly, and they will be integrated within the final design. Along the way of designing this prototype, there are many different things that we learned. One of the first things is that the relays that we bought do not work with the low output current of the Raspberry Pi. To solve this, we actually put 3 GPIO pins from the Raspberry Pi into the relay. We have also ordered Raspberry Pi specific relays that should solve our problem better than having to take up 3 GPIO pins for each relay. The next thing that we learned is that the first keypad that we bought was too cheap, and the soldering connections would break when we tried to connect them. The second has a bouncing issue with the buttons, such as when a button is pressed, it can sometimes be pressed multiple times, even though that was not the intent. To solve this, we are buying a USB keypad, so then we will no longer have the GPIO issues of bouncing. The third thing is that the database is most viable using SQL. We'll be using a SQL database moving forward, as this is an industry standard. Another thing that we learned is that carpentry is not as easy as we realized. Putting together the hatch was somewhat difficult and took longer than anticipated, and as such we will be allotting more time for that in the future. And the final thing that we learned is that in creating the EHS table, there is a lot more information outside of the table itself that we need to include. We're moving forward by creating a dictionary of all of said information, and that will be able to contain both the table and the non-table specific information. We will currently be demonstrating our physical hatch. As you can see, the lock is clearly in its locked state. We'll now be going and how to unlock it.
The first of our 3 methods of unlocking the hatch is a mag strip swipe reader. With this, any magnetic strip card can be used to open the hatch. As you can see, it's now unlocked and the hatch can be opened. If you swipe it again, the hatch is locked and cannot be opened. The next method is the physical keypad. For this, a simple key combination is set. So if you enter the correct combination, the hatch is unlocked and can be opened. If you lock it again, it's now locked and cannot be opened. The third method is a physical key-based system using a push button. A deadbolt will turn a key and depress the button and unlock the hatch. So as you can see, the hatch is unlocked, it can be opened, and it's now back in locked state when the button is unpressed. And those are our methods of unlocking the hatch, the 3 different prototypes we have made.
So the hatch is just 2 wooden boxes with a piece of plexiglass on top, and they're connected by hinges. So you can open it up and look inside. Looking inside the hatch, we have 3 different electromagnetic locks. This is going to be, each one will be each implementation as you saw earlier. And looking at the breadboard circuit, we have the power supply, a relay, and these wires heading to the Raspberry Pi. Currently, we only have 1 relay being used, and that is because we're using 1 lock for this demonstration.
Okay, so here we have the GUI for the ladder lock system. This will be displayed on our digital display for users to see the status of the lock or the position of the hatch. Now, let's say a user comes by, an employee, and they have the correct ID card and they swipe it, or they input the right code for the number pad, or they do it the mechanical way with a key and a deadbolt. Well, if that's the case, then the status of the lock will update and it will be shown on the GUI. Now that that's happened, I'm able to actually open and close the hatch, of course using a toggle switch here, but in the future, the Raspberry Pi will be communicating with our web server. That being said, let's say I leave the position of the hatch open and I try to clock out. Well, I would not be able to clock out until I close the hatch. And I would clock out the same way I would clock in. And then now the status is locked.
Okay, so here we have our EHS GUI prototype, and on the screen we are currently seeing the main page of the prototype. The main page includes a prompt, which basically asks the user for which building's health and safety information would they like. And under the prompt, there is a drop-down menu, which includes all the building names that are included on the EHS website's health and safety table. And let's say the user is currently located in Whittemore. They can scroll down and locate the building, which is Whittemore Hall. And after selecting the building, they can come down here and click the OK button at the right-hand corner, which then will prompt the application to run through the EHS table that is located on their website and pull out the relevant health and safety information. So here for Whittemore Hall, we can see that it has a unrestricted chemical hazard as well as a 1A fall hazard. And these health hazards are all displayed within a table. We do have to work on putting legend information associated with these fall hazards onto the display screen, but this is what we have so far.